Okay, it's 10 o'clock. I'm sorry, your time, Central Time, noon time. My time is 10 o'clock Pacific time. Okay, we'll get started. First thing is like this week we are on the introduction. And our lecture is covering the basic introduction for the robotics. So I don't repeat it again. So here you can watch the video from the lecture portion. Okay, here you do have the lecture, and then PDF is over here. You can always download the slices that I have for each lecture. So here you can download them. These are different one. Okay. So that you can download them. And also we cover the two lecture on the introduction of the robotics. We also cover the linear algebra and using Python model to model intelligent design. Okay. So this chapter's main idea is give you the overview of what we would like to do in this course. So basically covering what is robotics. Okay, and knowing basically the model, what is the basic model. And in the coming weeks, we based on the model to explore each individual boxes. So this model is a mathematical model. A mathematical model would eventually go into your design, robot design. Okay, we'll go into your robot design. So basically, in every piece of the hardware design or software design, we do come from mathematical modeling. So at that stage, we call it system modeling. And system modeling, sometimes we use math, computational information, and we do system modeling. We do have using math, and then we describe the block diagram. So at this time, actually, a lot of people use MATLAB for system analysis. Okay, and we use PyLab. Okay, Python language, and PyLab actually is NumPy plus the Matplotlib. Okay, I talked about it last time. So that's our tool. And move on from this stage to the next stage, you do build up your system diagram. Okay, so you build up your system diagram. So which part would be your CPU, which part would be your controller, which part is your actuator, which part is your AD converter, something like that. You draw down a system diagram, right? And then next one, from system diagram, you go into the implementation. So implementation, you break down into software design and the hardware design. And we call it hardware software co-design. Okay, you design both. And then at the end, you integrate them back. And because of the limitation, our focus for this course is primarily more on this portion, the mathematical modeling. And we spend more time on this portion. Okay, we spend more time on this portion. So that's the purpose of the introduction part of this course. Okay, so and the detailed things that we will cover it by this video. So you need to watch them. So right here, I'm going to briefly go over the slices. So if you have questions, you can let me know. Okay, I'll go over the two lectures slides in a very quick format. Okay. Any questions so far in terms of the discussion, homework, and other things? Any question? And if we finish this brief introduction of the material, I'm going to spend some time on Python. Okay, later. So let's get started first. Okay. First thing is the introduction. So here we talk about robotics. And last time we do talk about the robotics and the relationship with data science and AI anticipation. So data science need the programming skill plus the statistic, okay? And then machine learning is data science, and you also need to learn optimization theory. And optimization means you need to learn from historical data to improve your model. and also improve the pattern recognition ratio. Okay, and then you apply your machine you use a neural network to do deep learning. Then that's deep learning. Okay, and then you are use deep learning, machine learning, or data science into artificial intelligence. But you need to have some domain knowledge. And then robotics is including all the traditional algorithmic control and AI control and plus mechanism, mechanics, then mechanical engineering, and it's robotics. Okay, so that's about the overall knowledge you need to have. So robot is everywhere. Okay, robot is everywhere. I skip these simple things. So one thing I would like to talk about is the history of the robots. The history of the robots. The history of robot actually is starting from the robot arm. So in the early age, people just study the robot arm, okay, because that's called industrial robot, okay. And then later, the industrial robot come with the wheel. We put them into the agricultural environment, so we use it for farming or some other or battlefield. Then it's actually field robots. Okay, then after the AI being miniatured, so we become to have the iRobot. That's actually service robot. Okay, and nowadays we actually try to create more humanoid robots. Okay, both dynamic and medical use. Spatial applications such as the rover on Mars, and also drone in the battlefield. Okay, so these are the progress of the different robot, and it keep coming. Okay, robotics it keep coming. So one way to look at the robot is what is the robot and what is robotics. Okay, so robot and the computer. What is the relationship of robot and computer? Okay, this is very important. So since computer, you do have a CPU, you do have input, you do have output, you do have some memory. That's it. That's your I/O unit and your memory. And you have CPU, that's your computer. Okay. And robot is one kind of the computer. Okay. Robot is actually one kind of computer. So computer has computer architecture. You may take the computer architecture from your computer science course. Okay, every computer science major, you do have a computer architecture. So here we learn robotics. So robotics is actually the architecture of the robots. Okay, so it's a more advanced version of computer architecture. That's what I look at. Robotics is the computer architecture of your robots. Okay, it's the computer architecture of your robot. So basically, many things that we try to do, including the mathematical modeling and other knowledge we learn, really is to teach you how to build a robot. Okay, and how to build a robot. Primarily, we need to study the architecture first. In the computer, you do want to study the so-called instruction set architecture, right? You need to determine your instruction set, such as x86, okay, such as the M1, M2 Apple microprocessor, right? And in our system, same thing, you have to study your processor first. You have to study your computing model. You have to look at your system diagram, that including your actuator, manipulator, okay, actuator, manipulator, sensor for feedback, okay, and then going back to the loop control, and then planning, trajectory planning. So this is your system diagram. And in a way, this system diagram will be deployed to some sort of computing architecture as well. So that's what we look at as the system diagram for the robot. Okay, that's what we want to learn in this course. Okay. Okay, let's go back to the slides. So this history of the robot, it keep improving. So your system model need to change. Okay, your system model need to change. And we teach this course primarily to teach you how to look at the change of these different field, and also how to look at each component of your robot. Okay, and knowing that how you model it. So basically, in the beginning, we just have a robot arm that's for industrial use. So you only have an arm. You try to control it, right? That's industrial age. And later you add a wheel on it. So you have more actuator. You have your wheel. You have your tractor or you maybe a submarine unmanned submarine. So you do have your some sort of vehicle to carry your robot. Okay. So that actually is more, and then later you need to provide service. So when we go to the service, we do have better sensor, better feedback system. Okay, that go into the service field. So after the service robot, more AI being used. Okay, and then in the field or the industry control, these are more computer control. So traditional algorithmic control would dominate the first two stages, right? And then later, the service AI. Okay, I should say in this way: field robot in the recent version also have the AI. Okay, also have but here what I say is the older version of the field robot. Okay, early version they do not have much AI, but recently I think every field AI control all go into there, right? So. Because of the AI technology and the sensor technology being more much better than this the so-called robot become smarter and lighter and provide more service. Okay, so these are the different stages that we have. Okay, this is industrial robot. Okay, this is industrial robot. Farming robots. Okay, farming robot. Okay, this one is some sort of the kiosk robot. Okay, the service robot. Okay, so these are the different robots we have, and we need to know about different stages. So basic robot. Later we go into the analysis of human and sensor and the actuator. Okay, so this is your human environment. And you have brain, that's your control part. You have your arm, that's your manipulator. Okay. You have your eye, that's a sensor. Okay. So you, in the robot is actually always try to mimic the function of a human. Okay. And trying to replace human in a dangerous or some situation that human cannot go into, such as size, physical limitation. Okay. Those kind of things, we try to mimic the humans' behavior to do it. Okay, so basically, we are guiding the robot to become much more robust. So system design always is a key. You need to know about what you need to include in your design. So here we have another model. Okay, so this one we will talk about it later. But we started from the whole book is coming. We started from the manipulator first, and then actuator, and then sensor, and then control. Okay, that's the order that this course will go over. Okay, so the robot, traditional robot, including this one called robot arm. Robot arm, we always have something called wrist. We have elbow. We have shoulder. Okay, we have control unit. Okay, so first thing is that what is wrist and what is elbow, what is shoulder. Okay, this we have definition in the manipulator. You need to know. Okay, these are not just like, okay, I look at the shape and then it's wrist, this is elbow, or this is arm or something. So there is a basic definition for the robot. Okay, in terms of architecture, we do have some basic definition. So what is wrist and what is the robot arm? Okay, so you do have a robot. Okay, you do have a robot. You have a base over here. Okay, so that is a robot arm. So you have an endpoint over here. Okay, you have endpoint over here. So endpoint is over here. So endpoint has some XYZ. Okay, so starting from your base, you control your endpoint to any location, maybe a sphere, maybe a semi-sphere. The control of your XYZ when you actually move it, okay, no matter where it is, you move it. Anything that can be controlled to determine your endpoint's XYZ, we call it robot arm. Okay, we call it robot arm. So robot arm, actually, you can consider to be including your shoulder. You can include your arm, okay, including the so-called elbow, whatever. But some robot only has one section. So some robot may only have one section, right? Some robot maybe have two robot arm section. Some may have three joint, okay? 1, 2, 3, 4 to endpoint, okay, whatever. So we can only say that whatever control the endpoint is a robot arm. An arm in a wider sense, we can call it elbow, shoulder, depending on what you see in the robot. Okay, so that's actually the robot arm. So robot arm has such a definition. Now, next one, what is wrist? So in your endpoint, so let's look at the endpoint. The endpoint, you may have a, okay, that don't mean the endpoint. That don't mean the endpoint. So the endpoint, you may have rotor. You may have a clip, okay? You may have a clip, so your clip may move, right? You may have finger. This may rotate. Okay, so finger control and the rotator at the end, it doesn't change the location of the endpoint, but it do change the shape, the configuration, that how you use your phone, your robot finger, and how you clip something, how you actually take something locally. Okay, all these we could call it wrist. Okay, and wrist actually including the finger. Okay, including the rotor here. Okay, including many things, including the clip. Okay, and including maybe the finger sections. Okay, you can make several bend. Okay, so that actually is, we all call it wrist. So two main section. One section is control of your endpoint. That's your robot arm. And then the other one is your wrist. Okay, that's actually controlling your endpoint configuration. Okay, let's control your endpoint configuration. So that's the basic definition of that. And then at the end, you have some control unit, and maybe a computer. So far, this robot arm has no feedback system. Right here, this one has no feedback system. So it only is a robot arm. So usually this is a so-called industrial robot. You teach it how to move, you will keep moving in that way. Okay, and this one may have some feedback, but very weak feedback for this industrial robot. Okay, that's the robot. But later, this the simple robot arm model is not enough. We start to look at the more advanced version of the robot, including the sensor for eye. Okay, including the voice synthesis, including emotion control, including camera, including many things. Okay, so that becomes a humanoid robot. Okay, and this is the optimal shape that people are looking for. Okay, we do see some of the Boston Dynamic Robotics. Okay, so here, let me jump to here. Okay, and robot have different style. Okay, here you actually list down 9 different style of the robot. Every single one of them is called a manipulator. So this one is this manipulator represent the box we talk about. Let me see the manipulator. It represents the manipulator box that we talk about. It actually is talking about this one, manipulator. Okay. What action you would take. Okay. So that's a manipulator. So a manipulator, they do have the so-called six degree of freedom robot. We do have S, L, B, U, whatever X. So this name not important. Okay, just remember that they may several join. Each one of them we call it a join. Okay, each one of them we call it a join. Okay, each one of these we call it a join. Each one of these we call it a join. Okay, no matter what control it has. So it can be a rotor this way, it can be a rotor this way, rotor, and here you have a rotor this way. Okay, or you can have a extender. Okay, so there are two major types of the joint. One type is rotational, the other one is extendable joint. Two types, and the extendable one we call it prismatic. Okay, prismatic joint. Okay, anyway, that's the basic robot, and robot can be used into the production line. Okay, production line. So nowadays, a lot of computer actually is using chip design. It's actually using robot. Okay, one thing you may be surprised that actually some company, okay, some company that like the one that I talk about, the semiconductor manufacturing, Taiwan Semiconductor Manufacturing Corp. Their production line right now, I think more than 95% of the production line is automatic. So in chip manufacturing, everything is almost like no human just goes through a production line, and everything, most of them controlled by computers or robots. Okay, so because it actually already been highly automatic, very few people involved in the chip manufacturing process. Okay, so in a way, robotics is so important that it defines the capability and the efficiency of a country or a company's productivity. Okay, if you do not have good robotics, then your manufacturing process will be slow and actually not good. Okay, so nowadays, who is the leader in the robotics? Primarily is still Japan and the German. Okay, they still leading in the robotics. So their manufacturing power is more advanced. Okay, more advanced. Okay, so robotic manipulators. Okay, we actually have different manipulators. So here we do have a robot. And in our course, we use the abstract model a lot. So basically it's coming from the real robot. And we try to look at the joint extender, right? So extender is over here. And rotational joint like this, okay? And the base. So this, we try to extract the abstract model from the physical stuff, okay? So you actually can continue to move from this symbolic model to mathematical model, okay? So we build a symbolic model and then we build a mathematical model using XYZ and the theta to model your robot, okay? And then you basically do calculation to control, to design how you can control your endpoint and how to control your fingers. That's the whole purpose we try to have. Okay, that's the purpose we try to achieve. So mathematical model. Okay, it's given one. Manipulator type. We do have Cartesian. Okay, Cartesian because the Cartesian coordinate. So Cartesian coordinate is based on the XYZ. Okay, based on the XYZ coordinate. So this Cartesian robot manufacturing, you do control your things using let me see. Let's assume this is X, this is Y, and this vertical is Z. So basically, you are using the XYZ to control your endpoint. That's called Cartesian manipulator. And what another word called workspace. Workspace is based on such prismatic joint at the base where your endpoint can reach is called its workspace. Okay, you have an arm, you have a robot arm. Wherever your arm can reach is called a workspace. So let's assume that I do have a single base, and I do have a robot arm like this, right? So here I have an endpoint. Let's assume this one I can freely move this joint. So what this point can reach actually is a semi sphere. So something like this is what I can reach. But inside this sphere, I cannot reach. Okay, I can only move on the surface of it. So it's a 2D space, but it's actually a hot ball 2D space. And this one, we call it the workspace for my endpoint. And it is the workspace for the robot. So whenever we talk about workspace, it's where your endpoint can reach. We call it the workspace. Where your endpoint can reach, we call it a workspace. And Cartesian means you are using XYZ to control it. Okay, Cartesian means you use XYZ to control it. So we do also have the gantry manipulator. Here you actually gantry is actually usually when you do look at it at the shipyard or some location, you just move your location here, left or right, and top, up or down. Okay, usually for some system, okay, you can move that. Okay, and you can move this way. Okay, so this one you can also look at it as a Cartesian type, but it actually is moving in this way. Okay. Okay, that's the typical XYZ type manipulator, and we also have cylindrical manipulator, such as we do have a base. We do have a base that can rotate. Okay, and you do have a G that you move, and you also have the X that you can extend. So in a way, it actually the workspace is a cylinder. Okay, it's space cylinder. This type of manipulator, we call it cylindrical manipulator. So you can see that actually the workspace name usually is related to its workspace. Okay. Okay, sphere is that you do have the load, you do have the control here, but this one somehow you can move up down. So it actually is there's a center. You can actually move 360 degrees in everywhere, and you actually make circle here. So it become a ball. Okay, a ball type movement. Then that's a spherical manipulator. Okay, then there's a scalar manipulator. Scalar manipulator using two rotational joint. We call it revolute joint. Okay, sometimes I call it revolute joint. Sometimes I call it rotary rotational joint. Okay, it's the same idea. And then one prismatic. Prismatic means that you can extend something. You can extend in SY direction is called prismatic joint. So two rotary joint and one SY joint. We call it scalar. So scalar is something like this. Okay, you do have a rotation here. Okay, you have a rotation here, and you have extender here. This one is called scalar manipulator. Okay. Okay, these are different type of manipulator. Next one is anthropomorphic. Okay, whatever morphic is some kind of a shape. Okay, based on the word loop. Okay, so polymorphic in the Java language, multiple shape, multiple form. Okay, anthropo is actually human-like. Okay, so this is human-like. So you actually like the human arm. Okay, so you have the so-called elbow, arm. I'm saying it actually elbow, arm, and then wrist. Okay, those kind of manipulator we call it anthropomorphic. controller. Okay. And parallel means that you have multiple controller. So usually is something that you not only using one to control the endpoint, you have multiple control at different point. Okay. So this something like this is called a parallel manipulator. That means that it's only one joint, not one arm. It may have multiple arms together to control this thing. We call it a parallel manipulator. Okay, so we do have this different one. Superior wrist. Okay, this one. Okay, so here we don't. Okay, so these are the basic different type of the robots. Next one is mobile robot. Okay, mobile robot is the robot manipulator plus some sort of vehicle. Okay, so the vehicle can be fixed. So this one will be non-mobile robot. You may have wheel, you have a track. Okay, you may have leg, you may have undulating vehicle. Okay, whatever. These are the type when you have your vehicle carrying your robot manipulator, then we call it a mobile robot. Okay, so mobile robot, you have several ones. So you do have this fixed wheel, you do have a steerable wheel, you do have caster wheel. Okay, and you do have differential drive, more mobile. So this one is just like car. You have front wheel drive, back wheel drive. Okay. You have one wheel drive, three wheel drive. Okay. Different definition for your vehicle. Okay. Single drive mobile. So you may have three wheel you can move at the same time. Okay. But you need to do synchronization. When the three are in coordinate, it actually move together. We call it single drive. But some of them actually is tricycle. Tricycle is one wheel here in steering. Okay. Some of them is car, like you have two front wheel or back wheel that doing the drive. Okay. And there's omni direction. Omni is every direction. You can move in every direction. So it actually depends. Okay. The wheel also have many different ones. And you also have this the so-called mechanism, okay, wheel. It's actually we seldom see this one, okay, but someone actually designed that, okay. Okay, so here just briefly go over the manipulator and the vehicle, okay. Go over the different manipulator and vehicle. So the application, this one is a track robot with your tractor, okay. And that's your vehicle. So the base is vehicle. And here you do have a complex system that is considered your manipulator. Okay. They do have a remote control from somewhere, someone controlling this robot, or you may have an AI inside to control itself. Okay. And they may have sensor somewhere to sense its condition. Okay. So that actually is the control part. But this one is a unmanned ground vehicle, okay, used in battlefield. Okay, robot cleaning. This one, I think it also has a sensor. Okay, how far away from the wall? Okay, how far away from the vehicle? From the obstacle, and then where I have already traveled. Okay, so there's a workspace and there's a control and cleaner. Okay. And this one is the construction arm robot. It also has a tractor, and then there may be a operator, okay, to control it. Okay, this one is the lecture one. This one is lecture one. So that's the lecture one. Let's look at the lecture two, okay. Lecture two is the advanced robot. Here I'm not trying to go too detailed. So my purpose is just to give you some brief idea and also the key point. Okay, how to look at it, the key point and how to look at it. Okay, next one we do have industrial robot. This one more advanced one. We do look into the so-called industrial robot. Look into the automation and the statistics of the robot, and also field robot. Okay, field robot is something that replaces people in the battlefield or farming field. Service robot. So the previous lecture is basically classify the robot by the manipulator, and right here is classify the robot by the functionality. Companion robot, okay, different robot. So these are the different robot by its function, okay, and then look into the modeling and planning and control of the robot. And this one is a theme of this course, okay. That's what we want to learn. So let's go back. First one, let's look at the industrial robot. So industrial robot is pretty simple. The one that you use in the industry to replace human in terms of reducing the danger and possible harm. Okay, so here this is the industrial robot. And industrial robot usually is including these different things, including the computer vision to check something. Okay, computer vision to check something. Okay, and including the blockchain. You actually register the data for the product, and then knowing that where it's shipped, okay, and the parcel and who can pick up, and then my unmanned vehicle to deliver the product, okay. So that's that, okay, and then also the production line, okay, also the production line. Okay, so here you also, these are different industrial application. Each one application, they may have different type of robot needed, okay. So here, this one is industrial engineering. You do need to have this different kind of robot. So material handling robot, okay. Okay, this is a different robot automation. So one amazing thing is that something like the Amazon do have a very robot inventory management. Okay, so let's see, Amazon. Okay, inventory management robot. Okay, Amazon's inventory. Okay, Amazon use a lot of this type of the robot to carry its things. So the whole warehouse now can be purely be operated by robot. Okay, so that actually is very important. So reduce the human mistake, also improve the efficiency. Okay. Okay, this actually can carry a lot of things, so that's really amazing. Okay, nowadays your warehouse become a lot of robot moving around, chasing around. Okay, to actually take the product. Okay, to ship to the different department. Okay, so that's very important. Material handling by itself is very important field. Okay. Okay, some other robot, including robot arm, including the welding, okay, precision task, labor task, okay, or dirty task. These are some tasks that you would really like to have robot to help you, okay, and trying to reduce the use of human. Okay. Okay, this is a world statistic. I think I don't go over it because the number keep changing every year. Okay. And then the leader, we have four major one. Okay. German one, Kutka. Okay. And then this is three Japanese company. So Japan still be the number one leader in the robotics. Okay. In terms of most dominating company. And this German company actually already been acquired by some Chinese company. Okay, So primarily still leading by Japan. Okay. These are the company. Okay. These are the. This one is the Scala. Scala. So it's a 2-rotor, 1 extender type robot. Okay. This one's Scala. So it's usually used in when you actually try to pick something or drop something in the production line. This is Scala is very useful. Okay, and this one, okay, robot arm. Okay, this already is an anthropomorphic robot. Okay, so it's a 6-joint anthropomorphic. Anthropomorphic is more like a human. So something that is a 6-joint would be more expensive compared to the Scala one. Scala one, I think, is actually cheaper. Okay, so when you purchase the robot, it also depends on what is the functionality you want to achieve, and also how much budget you have. This one country robot. Okay, you do go in here and okay. So in a way, you can look at the car washing machine is also using country. Okay, car washing machine. Okay, and you can have this one with some sort of parallel control. Okay. Okay, this portion I don't repeat it. Okay, this company is Kuka. This one is the Japanese, German made. Okay, robot. And this is a multi-finger robot. So multi-finger hand sometimes is helping people to take something, and because it's a multi-finger hand, so the end point had more control on the material you want to handle. Okay, more control. Okay, such as handling a ball. And ultimate form would be the humanoid robot. Okay, people trying to design something mimicking all the human actions. Okay, this one like that. Okay, field robot provide a service. Okay, there's a number I skip it. Okay, such as then it's a Mars rover. Okay, from NASA. Okay, and here, okay, this one is okay. Service robot provide service. So nowadays we do see some of the service robot being used in the restaurant, such as ordering system, such as a food delivery system. Okay, we do see that, and also the electrical car. Okay, carrying people, and Amazon's self-driving delivery. Okay, kind of thing. And iRobot to vehicle. So these are the service robots. Okay, and precision control, that is robot used in medical field. So basically, this doctor is controlling the robot, okay, to do operation if you need watching. Okay, try to use it. So you no longer like using the human to do operations. Okay, and the next one is the toy or companion robot to design the robot dog. Okay, pets. Okay, Ashimo, humanoid robot. Okay, so this Ashimo actually is pretty powerful. Okay, so Ashimo and Boston Dynamics, these two companies are very interesting. They keep inventing different new one, even though they haven't found the application. So two companies, they are keep doing this humanoid robot. One is this company called Ashimo. So Ashimo actually soccer robot. So Asimo actually, well, they do try to actually start to use robot to play soccer. Okay, Asimo, this one, they try to score. Okay, and try to defend soccer. Okay, this one company called Asimo. Uh, they have many generations. So as is described here, since 1996, okay, the Asimo robot have been there, keep improving. Okay, Hyundai is behind it. Okay, Hyundai is behind it to do it. And another company is the Boston Dynamic. So these two companies trying to work on the humanoid or dog-like robot. Okay, so they are leading in the humanoid robots. Okay, so these are the humanoid robot. Humanoid robot, including the sensor and a lot of showing much better suspension system, much better sensor everywhere. Okay. One day, this Asimo robot may be very useful when it being sent to Moon or being sent to Mars or being sent to some locations such as the Arctic zone, okay, very cold locations or very dangerous location. They may be able to do something for people. Okay. Okay, so these are by the function. We do have this different type of robot. Okay. Finally, we come to the modeling and planning portion. Okay. So as I say, the modeling and planning is to build a mathematical model and to build a system diagram, okay, for the robot. So basically, the first thing is that you must know about what environment you will be have your robot to work on, and what signal you have, okay, and what's the basic model you need to have. So based on the different need, say your companion environment, your industrial or your medical use, okay, the number are totally different. Your car, okay, the sensor design, the whatever control will be totally different. So you need to base on the environment you want to work on to design your robot. Okay. Okay. So modeling is first you need to know about kinematics. Okay, how the scene move according to the XYZ and theta. Okay, and you need to know about the joint position and effector position and its orientation. Okay, orientation means different angle and different coordinate direction. Okay, so and then we need to solve the. So that's the first topic we look at is the kinematics. Okay, second one is the dynamic kinematics. When we would like to look at its motion speed, its acceleration. Okay, that's called dynamic kinematics. Okay. And then based on the dynamic and kinematics, we want to learn how to control the robot. Okay, how to control the robot. So chapter 1, we just have an introduction and give you the appendix using the algebra, linear algebra to understand the basic language. Okay. And then we start to look into chapter by chapter into the detail of the robotics. Okay. And then after we learn the kinematic and differential kinematics, we start to look at the trajectory planning. So you know where your end effector should be. You know where your manipulator should be. Then you start to do planning, how you control your manipulator so that you would go to your desired location at a certain desired speed. Okay. So that actually is the trajectory planning. Okay, and then we work on the dynamic model. Okay, and work on the planning portion. Okay, and then the solution, it can be probabilistic or heuristic methods. And then after we finish the planning, next one will be sensor and vision. Sensor and vision tell you where the feedback should be and how you control your planner and your controller. Okay, how you control your planner and your controller. That's actually the unit 3 on the sensor and the vision. Okay, and then also the actuator. Actuator is that how you make your things move. So when you got a sensor data, you got a trajectory planner, you decide how to work on it. Then you control your actuator to handle your manipulator. So provide some input number to control your manipulator, so that would achieve your desired speed and the desired location, okay, for your robot. Okay, that's the unit 3. And last one is your overall control. Overall control is the architecture. Okay, it's the architecture. So where the artificial intelligence being used, okay, so your AI plus and robotics. Okay, so robotics is a marriage between electrical engineering and mechanical engineering. Okay, and AI can control robot. You can also use a traditional algorithm to control it. Okay, either way would work. Okay, so here we do have different version of the robot. So left-hand side, we have a conventional encoder-based feedback system. So it actually is a pure algorithmic control. Okay, you use this one. And the second one is visual servo control. So the first one, you just use XYZ to control your robot. Okay, a standard control method. The servo means that you do have some feedback. Okay, and using algorithm to the feedback, and then you actually control your robot. Okay, last one is actually is you do have the feedback, and you do work on the learning model. So this one has the AI involved, and based on historical data, you actually to control your robot arm. So these are the 3 different generations of the architecture. Okay, when you talk about AI-based robot, we are talking about this one that comes with the learning model. Okay, and we started from here. Okay, just control the manipulator. Then we look at the sensor power quotient, and then eventually we look into the AI. But this one is not covered in the course because AI is a different course. Okay. Okay, so here we finish the brief overview of the week 1's material. Okay, any questions so far? Hello, any question? No question? Okay. This lab discussion portion is actually supposed to focus on the discussion. So if you have question, you're welcome to let me know what question you have. Okay, you're welcome to let me know what question you have. And and if no question, I'll briefly talk about Python. Okay, and then we will end today's talk. Okay, we'll end today's talk. So first thing is that you must have the Python interpreter. So you need to download a Python interpreter from python.org. Okay, and then here you have a download. You can choose the version you want to download and install it. That's the first thing you need to do. Second, you need to pick an editor, and we do suggest you to use the Visual Studio Code. Okay, that's more robust and can be used for different language. Okay, that's it. More robust and can be used for different languages. So that's the one we use. And third one, you need to install the so-called mathematical package that you need. Okay, so what mathematical package you need to have? You need to install numpy, scipy, matplotlib. This one you need to install this whole package here. Okay, so that's what you need. Okay, this is numpy, scipy, matplotlib, pandas, nodes. Okay. So this one is what you need to have. So for me, if you use a personal computer, to install it, okay, one moment, let me see. Okay, after you install Python, you may want to actually use this one called pip install. Okay, let me copy this one to the chat box. Okay, you can copy this one in your DOS prompt mode to install this IPython, pandas, everything. Okay, this one I posted here. NumPy, SciPy, matplotlib, IPython, Jupyter, pandas, SymPy, and nodes. Okay, these are the package we need, especially for at least you need to have NumPy and matplotlib. That's the minimum you need to have. Okay, even if you don't like the SciPy or some other thing. In this course, you will need to have at least the NumPy and the matplotlib. These are the minimum you need to have. Okay. Okay, so that's about the installation of the Python. Okay. After you install it, okay, last time we talked about the linear algebra, so I don't repeat the linear algebra portion. Okay, I don't repeat the linear algebra portion. So right here, I would like to do is go over the language briefly. Any questions so far? No question. Okay. So once you go into your Visual Studio Code, first thing is that you need to create a new folder for where you want to put your project in. Okay, so in this example, I put to my directory. So here I create a new one. Okay, I create a new one. Okay, I create a new one, PyLab. Okay, so here let me call it basic Python. Okay. Okay, so I put a directory called basic Python. I'm just covering basic Python. Okay. So last time we used the linear algebra. So we do know about how to create an array. Okay. But here I briefly go into the data type. So Python data type, okay. Python is a dynamic scope. Sorry, it actually is with type language. Okay, so there's not a lot of type. So there are very few type. Okay. So the data type in Python only has 3 types: number, string, and the so-called Boolean 3 type. A number type you can divide it into integer and floating point. So totally, the basic data type are only 4 types. But it's a weak type language, so you can assign the data or data type at any time. So there are 4 different type of data. So command you use a sharp. Okay, this is comments. Okay, so data say you have a data, so we have an integer. So I do I, you can assign 1. 40 point, I do 3.0. So these are 2 different data type. Okay, first one is integer type. Second one is 14 point type. And we do have a string. String and character is one type. Okay, so here you do have string. Okay, so there is no separate. Okay, child type or string type. Okay, so it's the same. Single quote, double quote, triple quote. They are all strings. Okay, they are all strings. Okay, they are all strings. And the number for data type is a Boolean type. Boolean type you can have assign a Boolean value to it. So these are the four basic data types. Okay, these are four basic data types. And that's the first thing. Second, all data in Python are actually objects. Okay, they are objects, so they all have the methods. So you can convert them into string. Just use str to convert a string f into a f string. Okay, so you can always convert it to string in this way. You can always convert a string into an integer if you use the integer to convert a 3.3 to a number. Okay, so basically the function, because everything is object, you do have different method that can convert your data right into the different format. As long as it actually is the right format you have, you can use that to convert it. Okay, so these are the data type conversion. Okay, data type conversion. Okay, so these are the four basic data type. I try not to work down too much. If you have some question about this different type, you can look at it later. Here, I try not to. These are very basic, so you just need to know about how to create them and then how to print them. Okay, those kind of things you can check the basic Python. What I want to do more today is the compound type. Okay, what is a compound type? So compound type in Python, they are string. The string you use a double quote, okay, or you use a single quote, or you use a triple quote. Okay, you create a string. Second type is tuple. Tuple you use a parenthesis. Okay. Third one you have the list. You use bracket. Okay. Fourth one you actually have a set. Set you use a curly brace. Okay. Last one is dictionary. Use a curly brace and then put the column inside. Okay. Your property versus value pair. That is your dictionary. So today, what I want to put emphasis on would be these different compound type. You must learn about this different compound type because in programming, we need use more of the compound type than the basic type. Basic type are very simple. Okay, compound type is the what we usually use. So first thing is that you must know about your string compound type. Okay, so string compound type is you have a text. So you can have a string, okay, equals 3.0. This one is a string, but you can convert it to a floating point. If you use a floating point function to convert it to floating point, okay. So and then you can print it. Okay, so this one is the so-called string operation. Okay, it's a 3.0. And you can check how long this string is by using len function. Okay, len function. The length of the string. Okay. Okay, the length is 3. Okay. Okay, so the length of string is find out. So string is the compound data type, and it tells us how long it tells us whatever inside this one is actually a string, is text, okay, is text. And string, you can use the so-called slicing to access your data. Okay, slicing, first part is called indexing. Okay, different from the Java or C++, Java's language. This one in, as a standard, we do have a string. A string, we assign A, B, C, D, E, F, G, H, I, J, K, okay, into it. So you can print out each individual item using the index. So here, let's try 3. So usually on top of this, I would put the number 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. Okay, so 3, you should get D. Okay, 3, you should get D. That's the so-called index. Index starting from 0. Okay, so you do have the index. You do get D. Okay, so here we can put it here. So that's called indexing. Okay, so single number is indexing. Okay, single number is called indexing. So S of 3 will be equal to this. Okay, single number we call it indexing. Indexing is used to access the individual data. Okay, multiple index, we call it slicing. Okay, multiple data, we call it slicing. Okay, slicing, last time we talked about it. When you have a string, you do have a starting index, ending index, and your step size. Okay, step size, sometimes I call it jump. Okay, 3 number. So when you have 2 number, okay, if you do have 2 number, your slicing for the 2 number will be start and end. Okay, this one equivalent to starting, okay, and end, and then jump by 1. Okay, your step size equals 1. Okay, that's the slicing. That's the slicing. So, but if this one actually say, let's assume that we do have S of 2 to 4. Okay, but 4 is not included, so E not included. 2, we started from 2 ending at 4, but 4 not included. Okay, one thing is that end is not inclusive. Okay, end is not inclusive. So this one, let's print this one. Okay. Okay, so you 2 to 4, not including 4. You get that. Okay. So this one is something like that. When you have 2 number, is from starting to. So this one in other language, we can also call it substrate. It's a creating substrate. Next one we do, if you do have starting, okay, S. First one, you do not assign number, and second one, you have an end. This one really means that you actually is starting from 0 and then ending at the end. Okay, and jump by 1. Okay, this one actually really means that. Okay, for example, we do have S. Okay, starting to 7. So you start from 0 to 7, but not including 7. You get A to actually A to G. Okay. Okay, so that's that. That's actually this slicing. Okay. So if you get started, okay, as you do have start, but you do not have end. Okay. This one really means that you are starting from your S of the start Okay, ending at the end, that would be the length of the S and then check by 1. Okay, it really means that. So print something like HAS, okay, 2, okay, 2 to the end of the string. Okay, so this one will actually be as from 2 to the end of the string. This one, okay, from 2 to the end of the string, from 2 to the end of the string, you get CD whatever to the end to K, okay. Okay, so this one is the slicing, okay. Slicing, we use -1. Next one, okay, we do have indexing slicing, and the next topic is negative indexing, okay, negative indexing. So negative indexing is that we do have this one, A, B, C, D, E, this one, right? So you can actually also use a negative index. Okay, negative index, this one, K will be -1. Okay, so let's do this one. Let's do actually 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, so it will start from, okay, this one actually will be minus, okay. So K will be -1, J will be -2, I will be -3, okay. So when you use the negative index, say you do print, okay, you do have a number, you do S, okay, you have the -3. It really means that your S is in S, okay, the length of the S -3, okay. So they take out this length word, okay. So something like that. So you do print. So -3, you should get 8, okay. 8 is I, okay. So here you can also use a negative index to the slicing, okay. I don't repeat that anymore, okay, because here I just teach you the basic idea. What is indexing? What is slicing? What is negative indexing? Okay. And one thing is that this index scheme, you can apply them all to the rest of the different data type here. Okay. So string is using double quote, single quote to you enclose the data type here. Okay. Enclose the data here. And then tuple is the same thing. You can also enclose them and you create tuple. The only difference is that whenever you enclose it by the string, string text. Okay, or you can look at it as the what array of characters. Okay, you can look at it this way. What is tuple? Okay, tuple is a fixed length data entity. Okay, fixed length data entity usually is something like points, locations we want to do it. So something like, okay, something like point one, you do 2 and 3. Okay, so here you do have 2 and 3, so it's a fixed length data usually for XY point. Okay, for 2D, okay, 2D. Or 3D, you can point 2 equals 2, 3, 4. This one is actually for SYD, 3D. Okay. So tuple usually is used for what? Fixed length. Okay. You can look at tuple as another way to look at it. Actually, is a fixed length array. You can also look at it as a fixed length array. Or in another way, you can look at it as a vector. okay, as a vector. So this is tuple. Okay, this is tuple. Okay, and last time we talked about shape. Okay, so let's look at this is a tuple. Okay, this is a tuple. So let's do here. We do have a array A equals. Here I want to actually use array. So right here, if I include import numpy as np here, is okay? Yes, it's okay. So here np.array, and you convert your tuple p2 to A, okay, and you print your A, okay. Okay, so it become a numpy array, okay, become a numpy array. But here P1, P2 are two vectors, two tuples. They are fixed length, so in a way you cannot make it longer or make it shorter. You cannot change them, okay? You cannot change them. You cannot make it longer or shorter, okay? Okay, and you can access individual data, so you can actually access print, okay, P1's 0, that you actually usually this one is to get your exposure, okay, get your exposure, okay. So tuple usually is used for vectors. Okay, you get 2. Okay. Okay, so this is tuple, but can you update it? So let's try P1's 0 equals 4. And let's put in P1 one more time. Okay, so tuple, you cannot update it. Sorry. Tuple, you cannot update it. So this is not okay. So it's a fixed length and no change. And we call it immutable. So you cannot update your data. Tuple is fixed length, no change. So you only can use data points. The only way you can change your data is you should try to create a new one. So you can do this one. You can do create P1 equals, okay, actually 4, and then P1's number 1, okay. By this way, you can change the first tuple, but actually you create a new tuple. You are not modifying your original tuple. You are creating a new tuple for it. Okay, you are creating your new tuple for it. Okay, then you can change it. But this one is not changing. It actually is creating a new tuple. So your tuple is immutable. You cannot change. So that's the first data type, compound data type we talk about is tuple. Okay. Second compound data type we talk about would be list. Okay. So this is different from tuple. So this we use the bracket. And different from the tuple is number 1. It actually is a principal length. You can add, remove, or insert, or append data to it. Okay. Second is mutable. You can update the elements in the list. Okay. Third one, quick conversion to numpy array. Okay. These are the key features for the list. Okay, so usually I do A list equals, let's try 1 3 okay 1 3 5 7 8 okay 7 9 okay, so that's R number 8 list. Okay, in a way you can add more data to it, so you say A list that append 11, so that's actually okay, we append 11 to it and then we print A list. So after appending, you add 11 to it. Okay, that's the first thing. You can append it to it. Okay, next one, you can actually insert some data in the middle of somewhere. Okay, so when we have a list, we do have some index. So index is 0, 1, 2, 3, 4. Okay, and 11 is over here. So 11 is index 5. But the indexing and sublist and listing, all the slicing and index rule in string can apply. Okay, can apply. So here, next one is that you can actually put some data into certain location. Okay, so you can do insert. So A list dot insert. Let's insert it. So here I do have data. I do have 1, 3, 5, 7, 9. And the insert location is starting from here. This is 0, 1, 2, 3, 4. So that's insert location 2 with 4. Okay. So insert location 2 with 4. And print now our A list one more time. Okay. Okay, so 4 being inserted to it. So insert append is in append to the tail. Okay, insert is insert to a certain location. So append to the tail. Okay, insert to the head. Okay, to the location. Okay. Okay, append insert. Next one is pop. Pop, you can take out the last one. You can take out the last one using pop function. So let's do this one. Let's do remove data. The remove data equals A list the pop. So you do pop and then you after the popping you print out the data. Okay, you do have A list equal to A list. Okay, that one you take out 11. Okay, and we also want to see who got removed. So let's do print out. So the removed data would be equal to removed data. Okay. Okay, so that one is 11. Okay. Now I may also want to actually, this one is pop the tail. Okay, this one is pop out the tail. Now sometimes I want to remove, say I want to remove this 4. Okay, so you actually let's look at this one, remove data. Let me actually say this remove the data equals A list that pop 2. So keep the index, you can remove the data. Okay, so we this one and then we do this. Okay, so 4 being removed, so we take that out. Okay, so next one we do actually next one, let's assume that we do want to have the A list number 2. And this 80 is the metonymy have the even number. Okay, 2, 4, 6, 8, 10. Okay, and I can connect the two together, so I do have the A list 3 equals A list 1 plus A list 2. And let's print my A list 3. Okay. Okay. So this one we use the plus sign. Plus sign means the concatenation. You actually connect the two lists together. Oh, I'm sorry. A list. Oh, there's no A list. It's called A list. Okay. A list. There's no one. Let me wrong it. Okay. And this one becomes like this. Okay. And then after that, you may want to sort it. So I say A list 3, A list 3, that's sort. And then there's a print it, okay. A list 3 that equals A list 3, okay. So after sorting, let's see how after sorting. Let's look at it. After sorting, data being sorted, okay. So here, why I spend more time on the list? Because list is strongly related to array, strongly related to our metric. And list can provide the operation to the array. So here I can do A array, okay. A array. So A array would be equal to numpy.array. Okay, when we put the A list into there, and that's print array, okay. That you make it an array, okay. And you make it an array. And this one is a set, okay. So set is usually using the set operations. So we do have a set. Let's use a set that actually is A, B, C. So let's assume that we do have this A set that has A, B, C. So B set, B set that have the so-called A, okay, B, okay, E. Okay, so this is two set. Okay, these are two sets. So let's do have the C set 1 equal A set. Okay, A set. Let's do union. Okay, union with B set. Okay, so union with B set. There's no plus sign. Let me see. Let me use the union. Let's use all. Okay. So this one bar is actually union. Okay. One bar is actually called union. It's vertical bar. Okay. And then C set number 2 equals A set end. Okay. B set. This one is intersection. That's M mark. Okay, so let's point. Okay, this one is the union intersection. Okay, And if you want to check if a number is inside the set or not, you can do if A, okay, if A in set one, okay, you say print, okay, A is in set one, else, okay, print A is not in set one, okay. That's the membership check, okay. Oh, C set one. I'm sorry, this one is A set, okay. Okay, so that's actually a member based test, okay. Last one, we talk about dictionary, okay. So dictionary including the tuples. So let's assume that we actually try to create tuples. Okay, so here we can create, it is tuples, it actually can also be considered as map. So sometimes we call it dictionary, sometimes we call it map. Okay, sometimes we call it map. Let's assume that we do have a dictionary. Okay, that's called D, okay. And this one, we can set the data as this. Okay, let's assume that we do have A, okay, mapping to 1. B, we mapping to 2. Okay, we do have C mapping to 3. Okay, we do have B mapping to 4. We do have E mapping to 5. Okay. So dictionary creates such a mapping you can create in this notation. Okay, and you can put in this D. Okay, you can put this D. Okay, and in a way you can actually query it. You can query it. So let's print the properties of these A. Okay, you can query it. Okay, you can look at it in this way. As long as this is dictionary. Okay. Okay, I'm sorry. This one because you want to use a code, so you need to use escape sequence to bypass it. Okay. Okay, no problem. Okay. Here is this one. Okay, equals 1. Okay. You can query. That's the basic operation you can query. Now here I just try to give you some basic. Okay. So one thing is that you have a dictionary in this property value pair. So your properties, you can use the keys. You can get the properties values. You can use the theta values. You can get the values. Okay, so let's print out the so-called properties. Let's print out the so-called values. Okay. So you can separate into two things, and they do call it key, okay, and value. So right here, you can actually make them as list. Okay, it's a dictionary instruction, but you can make them as list. And then you can use that using this to operate it. Okay. So let's actually do this one. Let's actually cut this one out. Okay. Let's put it here. Okay, let's put it here. Okay. Let's call this one as P list. Okay, and let's actually cut this one here. Let's put here as a list, value list. Okay. So list. So we create two lists. One is A list, P list. One is P list. Okay. So it actually is something that is we can separate them. And also you can also do tuples. Okay, let's call it dictionary tuples. So D tuples. So D tuple is user D items, and then there's a print now. Okay, print now is a D tuples. So once you use the tuple items, you actually will create this thing called D tuples. Okay, and then you can convert them also to tuple. Okay, you can convert them to tuple. Okay. Okay, you convert it to tuple. You can also convert it to list. Okay. So it's a list of tuples. Okay. So make it as a list of tuples. Where is a list of tuples? Okay, so here we do have P list and V list. Okay, we can also do zipping. Zipping can combine them to tuples. So here, zip tuples equals list. Okay, you use the zip of your P list and the V list. Okay, and then you bring your G tuples. So then you can zip your two list key and value back to list of tuples. And then you can actually convert it back to recover the dictionary using the dictionary function to put in your G tuples. Okay, and then you print out your recover the dictionary. Okay, so that's that. You get your dictionary back. So what I'm trying to do right here, I do create this different thing is, okay, originally I do have a dictionary. I do have a dictionary called D. So I create the D the keys to create P list. I use D the value to extract the value out, so it becomes V list. Okay, and these two things I can zip them back to G tuples. And G tuples, I use a dictionary function. I can convert it back to the dictionary. So this one is how you extract the value and how you assemble it back to the dictionary. Okay, so right here today, I try to cover the conversion of the different compound data type in Python. Okay, hopefully this will be helping you in terms of converting the different data type, compound data type, and will help you in when you do Python programming. Okay, so I think today I'm going to up to here. Any questions so far? No question? Okay, no question. Thank you for participating. Okay, thank you. See you next time. Bye-bye.